Hello, welcome to Computer Science E1. This is a workshop on digital photography. My name is Dan Armendariz. So let's start out with a bit of a pop quiz, if you will. I have here a box and a cell phone. And I want you to tell me which one of these is a camera, or could be a camera.
Both of them.
Yeah, both. Okay, so hopefully then all of you are aware of what are called pinhole cameras, where if you had a box that's better than this and enclosed, you can actually put a piece of film in it and poke a little hole in one end and actually set it somewhere for 4 hours, 5 hours, and in the end you'll have a photograph. So the point of this is that you can actually have things that are a wide range of devices that are cameras. Today we're going to talk specifically about digital cameras, but you should realize that a lot of the terminology from film cameras moves over into the digital realm for our convenience, and also so that there's a lot of interchange between the two formats. So one of the main things to recognize is that digital photography is still photography. It's still just like a film photo. So like I mentioned here on the notes, a digital camera is still fundamentally the same as a one-time use camera. It's still fundamentally the same as a pinhole camera, such that there are several major factors that are the same between all of them. First one is that there's usually a way to frame the photo that you're about to take. In a regular camera, for example, or perhaps in a larger camera, you would have a viewfinder where you put your eye up to it and you can then frame the scene that you're about to take a photo. In one-time use camera, it also has a viewfinder. Maybe a little hard with a pinhole camera, but you can kind of tell just in terms of where you aim it. Next thing would be a mechanism to focus light. Now normally, this would be a piece of glass, like this lens here, that focuses the light coming in one side, focuses it out of the other side and onto the film plane in the camera. Now with the pinhole camera though, there is no glass. It's only the tiny, tiny hole at one end that focuses the light onto the film plane. The next would be there's a mechanism that can control the entrance of the light to the sensor or to the film. Usually this is a shutter. So you may recognize from film cameras, you hear the noise every time you take the photo, the very classic photograph noise with the clacking shutter. That is the shutter opening and closing to let light into the film. In a pinhole camera, I keep going back to this, but it's just to illustrate the fact that even a very basic device can be used as a camera. In a pinhole camera, all you have to do is have a piece of duct tape over the hole. When you're ready to expose it, you open the duct tape. 4 hours later, after you get a very nice long lunch, you come back, you put the tape over, bam, your exposure is complete. Next, light shines onto a film or onto a sensor for recording. Now, with the advent of digital photography, the mechanism for recording is a little bit different, because in film, the photograph is recorded directly onto the film, but in digital photography, it's recorded onto a memory card. This doesn't matter. There's still a device that captures the light in the scene for recording. So the differences between cameras are in the exact implementation and the exact details of these steps. But it's convenient, like I said before, to think of digital cameras in terms of film cameras. I think that one of the huge things about this course is that we try to get you more comfortable with computers by telling you a little bit how they work, by giving you some background on how hard drives work, how the computer communicates between its devices. This helps you, at least we hope, it helps you get a better understanding of computers, makes you more informed so that you can purchase a computer that you know is right for you, so that you can use a computer the way that you want to use it. So similarly, I'm just going to talk about, for a while, some things about cameras, about photography in general, before I relate it back to digital photography, so that everybody knows, is comfortable with it, and we can just jump right into digital cameras. So first thing about a camera is exposure. So what is a photograph? It's basically just something that records, well, it's a medium by which we can record light. So we may have a scene, a rectangular scene, if I could draw more straight, and we have a tree on one side, we have a person in the middle, for example, we have a car. All we're doing with the camera is recording the light projected by the scene or reflected by this scene. Oh, thank you. Now, this is very similar. This is a way that we can use, just like we have vision, we can capture, capture the Kodak moment, for example, as they would say, by recording it permanently, not so much in our memories, but with a camera. But you have to realize that there are differences between a camera and the way that we work. So our eyes are amazing things. We have rod cells and cone cells, and each rod and cone cell can actually adapt to various degrees to different amounts of light. So you could, let's say we were looking at this scene drawn here. You could actually have the sun in the background, for example, and even though you're in the shade of the tree, you can see details in the shade of the tree, and you can see very bright portions of the sunlight. That is because when the light enters your eye, the portions that are dark, those cells kind of adapt a bit so that it perhaps in a way brightens up the scene a little bit so you can see and understand the details in that scene, whereas the rest of the scene is still very bright and your eyes adapt so that it's easy to see the details there. So you can have a huge, what's called dynamic range in the brightness of a particular scene. Cameras, however, you have to realize there's a huge technical limitation to this. They cannot do what our eyes can do. You can set one exposure, so you can set a certain range that a camera can detect, and it will only detect that range in the entirety of the photograph. So that is why if you are taking a photograph of this scene and you can see the detail of the tree and you can see the detail in the sky, so you can see the clouds, for example, if you try to take a photograph, the dynamic range is not as high, and you will only see, depending on how you expose for it, you'll only see the sky and the clouds, and you'll see the tree as a dark silhouette, or you will see the tree properly exposed and the sky has suddenly turned bright white. So let's talk about exposure. Understanding exposure is key because this lets you master the physical limitations of a camera. This will let you know what kind of camera is right for your needs. This will help you focus less on how bad your photo looks and focus more instead on the contents of the photo. Maybe we'll talk about different things such as if you have a young child, for example, that likes to run around, we'll talk about when you want him to be blurry so you can portray motion versus when you want him to be still so you can see what he's doing. Basically, if you master exposure, you can take a photo without worrying about the quality of it so much as the contents. So let's move on. Since photo is made through light, it's important to know how this photo or how a camera can manipulate light. So there are 3 ways that a camera can manipulate light. Like I said before, the film of a film camera or the sensor of a digital camera have a limited range of light that it can accept and record. If it's too much light, it'll appear bright white. It'll appear white and your photo will be what's called overexposed. If it's too dark, it'll be underexposed. You'll lose all the details in either overexposure or underexposure. You'll have no details in the photo at all. So you may recognize this if you take a photo of someone that's backlit. Everyone says don't take a photo with your subject between you and the sun. That's because the background will be completely blown out. It'll be completely overexposed, whereas the foreground will be okay. So there's 3 main ways that a camera can manipulate light, manipulate the intensity of the light so that it will be properly exposed on the film sensor. There's the sensor sensitivity, or ISO. There's the aperture, which are known as f-stops. There's the shutter speed. So let's think about some of the most obvious ways that we can use to manipulate light. So how do our eyes work? We have the iris that opens and closes, for example, when it gets dark, or when it gets dark, it opens a little bit more to let more light in. It physically lets more light in. This is similar to the aperture of a camera. Now, let's say you were, I can't think of a good analogy. I was coming up with crazy analogies the whole time during section, and so I think I'll pass on that for now. But in the aperture of a camera, I think this is actually the hardest one to understand, but we'll get this out of the way first. So here is a somewhat typical lens for a camera. Now there's a front element, which has a certain diameter, and then there's a certain length, what's called the focal length of this lens. Now the focal length basically determines how zoomed in or how zoomed out the photo appears. So if we have what's called a very long lens, in a 35 millimeter camera, for example, you might consider 200 millimeters to be a long lens. It'd be large, and you would use that perhaps for sports. But you might have a short lens instead, say 20 millimeters, which would be more akin to taking this entire room into one photograph. Now, the reason that the focal length is important is that the aperture is a ratio of the diameter of the front of the lens to the focal length. Now you may say, well, what does this matter? This is just like the iris of your eyes. If you have, basically, let's consider the lens maybe like a hole for light to enter. If you have a very large hole, you will allow in much more light. But if you shut this down to be a little bit smaller, then you will let in much less light, right? So because it's a ratio of the diameter to the focal length, this can actually lead to some trouble. The numbers are not quite as nice. So some typical apertures would be, for example, 2.8 or 4 or 5.6. So these don't necessarily look like very pretty numbers. If you looked at one, you may not say, oh, okay, I kind of know what to do with this. But let's think about this just in terms of the ratio of the diameter. Because it's a circle here, when you make the circle bigger or smaller, you're actually changing the area. I'm losing people big time. Okay. Let's do this differently. Let's start instead with shutter speed. So in a camera, when you open the shutter, it lets in light. When you close the shutter, it stops letting in light. So you can imagine that there's a time frame between the shutter is open and closed. This is called the shutter speed. If you have, let's say, a 1 second shutter speed, so that the shutter is open for 1 second, then it closes after that second, you let in a certain amount of light. Okay? So what happens then if you have that? You now have half a second shutter speed. What this does is literally lets in half as much light. So where we have a 1 second exposure, we can then make the scene brighter by making it 2 seconds. By making it 2 seconds, we are now letting in twice as much light. So if you're taking a photo of a very dark place, for example, maybe you're taking a night photo, you would have to bump up the amount of time that the shutter is open. This may be obvious, but if you keep going down half second, for example, you now let in much less light. All of this makes sense? Okay, good. Now I see some happy faces. So let's move on to film or sensor sensitivity. So there is actually an amount of choice that we have in terms of the sensitivity of a camera. If you are in a dark room, you would want a sensor or a piece of film that is more sensitive to light than if you were outside, for example, and there's lots of light, then you don't need something that is as sensitive. Now, whereas shutter speed is measured in seconds, this is measured by something else, a little bit more arbitrary, called an ISO rating. So if you ever go to CVS, for example, and purchase a one-time use camera, you may notice they say, this is ISO 400, good for indoor shots with flash or outdoor movement shots, for example. Or they might say ISO 200, which is good for fast sports in bright daylight. Now, the ISO typically starts at about 100. Let's just say that there is a given amount of sensitivity at 100. Now, what's nice is that if you double this number, just like the shutter speed, you are doubling the amount of sensitivity. So ISO 200 then is twice as sensitive as an ISO 100 piece of film. So digital cameras also have a setting like this, where it's similar to, but not exactly the same as a film ISO. You can actually define in digital cameras which ISO setting you want. 100, 200, 400 are all very, very common in digital cameras. Now you're seeing more 800, and in some cameras you see 1600, 3200, even 6400 ISO. So you can see that this would be quite sensitive compared to the ISO 100 of a typical camera. So let's think for just a minute about the pros and cons about sensitivity and the shutter speed. Let's say that one of you is a professional athlete, and I'm taking photos of you as you run across the field, for example. So let's say I take a photo of you at ISO 100 and a half-second exposure. In that half second, you actually move quite a few, well, I don't know, maybe inches at least, depending on your speed, maybe a foot or more. So in that time, the camera has captured your movement. If you're running in this frame, half second, your camera has captured that much movement, and you will look very blurry. So what is the way that, if this is properly exposed, so that we don't want to change how bright or how dark the scene is, how can we make it so that you look less blurry? What can we do with these settings? Well, we can make the film more sensitive, okay? So we move from ISO 100 to ISO 200. Now that the film is more sensitive, that means that this will be brighter, correct? But it was properly exposed, and I don't want to do that. So let me make this 1 second half as slow to half a second. So now what my shutter is doing is it's open for half the time. It's letting in half the light, but my sensor is now twice as sensitive. Okay? So now the scene looks the same, but instead of moving this much in your photograph, you're only moving this much. So my artistry and stick figures is not as good as other media, but I hope you get the idea. So basically, if you're taking fast action, what you generally want to do is increase your ISO and increase your ISO and also increase your shutter speed. And what I mean by increase your shutter speed is, because we're talking about speed, faster is more, right? So half second is a greater shutter speed than 1 second. So by increasing your ISO, you're making it more sensitive, and you're allowing yourself the opportunity to freeze action. But what could be a downfall to increasing the ISO? Well, in any case, maybe just like if you turn up the amplification in your stereo, for example, you may hear more problems. The amplification problems, it sounds a little bit more grainy, or you hear popping, something similar to this. You also get noise in the system from a digital camera. This also happens with a film camera. You may notice that photos with a very high ISO look very, very grainy, not only in digital photography, but also still photography as well. This can be a problem if you want a really clean shot. If you want a really clean shot, you don't want grain, then you can't afford the luxury of increasing the ISO. So as you'll quickly come to realize, when we're talking about exposure, what we are going to do is compromise. Compromise in everything. When we throw an aperture, it's going to get even more complicated because there's yet another factor that we have to consider. So, good. So ISO, shutter speed, so far, everything making sense. Now, let's do a better job describing the aperture. So let's just say that we have a circular lens. Okay? It's a big lens, and it is letting in light for my photo. So I have, let's say, ISO 100, and I have maybe a 250 second shutter speed. Now, when the shutter opens, it's letting in light from this lens. But what were to happen if I had a similar lens where the front element was smaller? I'm letting in much less light. So by letting in less light, I'm actually changing, for these fixed values of the ISO and the shutter speed, I'm actually still changing the exposure. So by having a smaller opening, my photo is going to appear much darker given the same settings here. So far, so good? So the aperture then is just a ratio involving the diameter of the front element, of one of the elements in your lens. And you have control, in most cases, over the diameter of this particular element. Now, what's interesting is that actually changing this will do a lot to change the appearance of your photograph. Just like changing the ISO will make it more grainy, or changing the time will either freeze action or allow movement to be shown. This will actually change the amount that appears sharp. So when you focus in on a particular subject, let's say you're doing that sports scene again, you can focus in on that subject will appear sharp. If you change the aperture, you can change how much of the subject appears sharp. So I actually think that one of the most interesting ways to show this is actually to do ray tracing. That's where we follow a path of light as it enters into the lens. So let's say we have the film right here, okay? And so light normally comes in this lens, and it gets refracted, and then it gets put onto the film. Now, when it's focused on something, there's actually, there's two rays of light that come in, and usually if it's supposed to be sharp, it should form a point on the particular film. But it's possible, let me draw it in the center instead. So let's say we have light coming into our lens here. Let me do this differently still. So if we have two rays of light coming in, they form a point on the film plane. This appears sharp. So the subject that these rays are coming from appears sharp in this case. If the film plane were moved back to here, for example, it will appear to be fuzzy or out of focus. That's partially how focusing can work, is that it moves a set of elements such that the rays that converge at different places are then focused on the film plane differently. But let's consider then that we have a much smaller aperture. So now when we have rays come in, they're much more elongated. Oops. And since it's narrower here, we actually have a wider spot that will appear to be sharp. So what this means is that if you close the diameter of your lens, not only are you letting in less light, you're also increasing the distance that appears to be in focus. So there is always a point that's a central focus, that is the most in focus, if you will, of everything in a photograph. But there is also what's called the depth of field. The depth of field is the distance behind and in front of the absolute focus point, that where things appear to be sharp. So a smaller aperture equals large depth of field. Depth of field. But this also lets in less light. A larger aperture has a much shallower depth of field. So you can literally, with some lenses, focus in on someone's nose and their eyes will be slightly out of focus. There are some lenses that are that sensitive to depth of field. So the large one will have a shallow depth of field, but will let in much more light. So now we have three things that can affect the exposure. So let's talk about some of the numerics for this aperture. I talked about it being a ratio. I started going into the area of the circle and everything, and that's a lot of math that I probably shouldn't go into. But just if you consider the fact that it's a circle, right? It's a circle that's letting in an amount of light. So when you make half the area of the circle, it's letting in half the amount of light. But because it's an area, it's not going to necessarily be as nice as doubling or halving these values were, for example. So the easiest way to remember this is to just start out with the two values, f1.0 and 1.4. These are very, very large apertures. These mean that you have a very, very large diameter for your particular lens, okay? So the higher the number, in this case, the smaller the aperture is going to be. And that is because that it's a ratio of stuff, so just take my word for it, in this case, that it's going to happen in this case. So let's just double these. So an f-stop of 1 times 2 is 2.0. An f-stop of 1.4 times 2 is 2.8. And just keep going in that pattern. 2 times 2 is 4. 2 times 2.8 is 5.6. We can keep going. 8, 11-ish, 16, 22, and so on and so forth. Now these are actually very common values for the f-stop. Now I'm talking about f-stop. When I say stop, I actually mean an amount of light. So if you have or double the amount of light coming into the frame, that is called a stop. So let's say we have ISO 100. We can actually have a stop faster of light by increasing it to ISO 200. Okay? Similarly, we could have 1/250th of a second shutter speed, and we can actually make it a stop more light by saying 1/125th of a second, right? Because 1/125 is a shorter amount of time. It's a longer amount of time than 1/250th of a second. So similarly, between each of these numbers is a stop. So by setting your lens, changing it from 2.0 to 2.8, you are letting in half as much light. Okay? So there's actually a general rule of thumb. For bright daylight, we can have, if we go back up here, for bright daylight, we can have ISO 100 at 1/250th of a second at about stop f8. And so we can go from there. So let's change some of these things and try to figure out what they do. Let's say that I'm taking photographs of sports, so I want a faster shutter speed. Well, one of the things I can do is change the ISO. So in terms of exposure, in terms of how brightly lit your photograph appears to your camera, let's I lost my train of thought. So if, in terms of how bright this appears to your camera, we can make this unchanged by changing two of these values. So we have many options from here, of course. We can go from ISO 200, so it's now twice as sensitive, but since it's sports, I want it to be a faster shutter speed. So we can go to 1/500th of a second. And now I can capture action twice as fast as I could before. But f8 will remain the same just because we've already done enough to balance out the exposure. So there's still more we can do. Let's say we wanted to keep this 250th of a second. Maybe we're just taking portraits outside, and 250ths of a second is enough to kind of capture someone holding themselves still. But we want to blur the background a little bit more. So we want a shallower depth of field. We would then change the f-stop here. So we have 250ths of a second. We want a shallower depth of field, so we would change it to f5.6, right? So remember that I erased it already, but it was 8, 5.6, 4, 2.8, 2.0. This is a pretty good range here. So remember that a smaller value here means that it's letting in more light. Now we have a couple of options then. We can either decrease the ISO so that it's less sensitive, but ISO 50 you don't see very much. So we probably have to say, okay, let's change this to ISO. Let's keep it at ISO 100 and then instead just make it a faster shutter speed, and that's perfectly okay. So all of these exposure values are actually the same thing. Now you're probably saying, okay, this is really boring. How does this relate back to what we want to know? When you're purchasing a digital camera, digital cameras have different amounts of limitations in terms of these three exposure settings. So some of them, for example, have a shutter speed limited to about 15 seconds. That sounds like a long time, but if you're taking a night shot, that might be kind of limiting for you. Some of them have fixed apertures such that you cannot change. There's a physical limitation where you cannot change the aperture of the camera. And why is this bad? Well, you may want to change how much is in focus. You may want to have that sort of artistic control over your particular camera. Another thing would be ISO. And I'll talk a little bit more about this in a second, but especially very small cameras have trouble getting more ISOs, or have trouble getting a range of ISO outside of, say, 100 to 400. Sometimes it's just difficult for it. Now you're seeing more 800s, but, well, as you'll see in a little bit, in terms of digital cameras, bigger is most of the time better. So does everyone understand the relationship between these three things here? Okay. So I actually have an example for you. Real-world examples of let's see. Real-world examples of photos. And did we lose our... Okay, it's coming up in just a second. So here on the screen are two photos. They were taken one right after the other of a lake in New Hampshire last weekend. And I captured what's called a star trail photograph, where the lines that you see are actually the stars moving across the sky while the shutter was open. So the one on the left here, I left my camera out on the dock for 15 minutes with the shutter open so that it could take this photograph. Okay? But what is the major difference that you notice between the two photographs? The star trails are different lengths, right? So you can particularly see here, I believe this is the star Vega, that in the one on the right, it's approximately half as long as the one on the left. Now, with it being longer, it's a bit more dramatic. I think it shows the motion a little bit better. So but you notice, though, that they look to be about the same brightness. Okay, so what did I change? What is different between the two? Okay, shutter speed, right. So the one on the right is about a 7-minute exposure or so. The one on the left is a 15-minute exposure. But like I said before, they're about the same brightness. They're not because of some color issues, but they're about the same brightness, so I had to compensate with that. So what were the different ways I could have done that? If I have a longer shutter speed, then I can that means that I'm letting in twice as much light, so I can either decrease the sensitivity, make it less sensitive, or I can I can close down the diameter, I can close down the aperture a little bit more. In this case, let's zoom in a little bit. And what do you notice about the sky on the left side to the right? The one on the left, I'm not sure if you can see it terribly well, but it's actually a lot cleaner. There's not as much noise. So what I did in this case was I changed the ISO from 800 to 400, and so not only did that give me a more clean image, but it also, at the same time, allowed me to get the more dramatic star trails that we see here. So, great. So that's one example. So here I actually have a photograph that's not particularly interesting in its own right, but only in that we can see the dynamic range problems that we get when we try to photograph something that is very dark and very bright. So what we should be seeing here, and what you can't really at all, is that there's beams here at the top of the bridge. There are clouds in the sky. But you can tell now that this image is both over and underexposed at the same time. These are areas of underexposure because we've lost detail. There's not enough light for the camera sensor to recognize the detail in this image. And in the sky, we can see that it's all white, meaning that it's overexposed. We've lost the detail there. Situations like this are very difficult to do. Usually you can enable the flash mode on your camera and try to flash and add extra light to this, to the bridge, but this is a very long bridge. I would not have been able to do it. In this case, I just junked this photo because, one, it's not interesting, and two, it's difficult to get the proper exposure. So then let's talk a little bit more about digital cameras specifically. Everybody has heard megapixels, correct? Megapixels this, megapixels that. And every year there is a camera that comes out with megapixels that beats out the previous year's model. And now everyone says, oh, this is so awesome. I'll be able to capture so much more information or so much more detail from the scene with this new megapixel camera that it's worth it to buy over a smaller megapixel camera. I argue that this is not the case. And let's go into some detail about this. So we have a digital camera sensor. It's literally a piece of silicone that detects light, and it's a certain size. It's a rectangle, and this rectangle detects light when light is shown on it. So let's say that we have a specific size for this rectangle. I actually have an example. So in my own digital camera that's here, this one here, we have a sensor size of about 22.5 millimeters by 15 millimeters. Think about that. That's not too big, okay? That's 2.2 centimeters by 1.5 centimeters. So that's just under an inch width and, 3/4 of an inch tall, for example. It's a little tiny thing, that huge camera. Now, the ones that you find in most digital cameras today is actually one that's about this size, where it's 5 millimeters by 7.2 millimeters. Okay? Much, much smaller, but this also allows the camera to be much more compact. You're saying, well, that's cool. I mean, that's a lot better, right? Not necessarily. In the camera sensor, there are tiny little blocks. And these blocks detect the light. These are what give you the pixels, okay? So on this particular sensor, on mine, I have something like 3,300 by 2,500 or so. You multiply them together, and you get the total number of pixels in the image, or 8 megapixels, okay? So I have an 8 megapixel camera. So, but let's consider the fact that this sensor is 8 megapixel, okay? The smaller sensor is 8 megapixel. So what happens then to these photosites, the sites that detect the light? What happens to them in this sensor here? They're much, much smaller. Much, much, much smaller. So I have to throw out this analogy, even though I've been doing a terrible job with them today. Let's consider photosites to be buckets. Let's consider light to be rain. Let's say you put a whole bunch, thousands of buckets, so you had an 8 mega bucket resolution, okay? And you were capturing rain. You wanted to maybe observe rain pattern over the city of Cambridge, for example. So if you have big, wide buckets, it'll capture certain amounts of rain. But if you have narrow buckets, your error is going to be much greater, especially if it's in a drizzle, right? So if it's not raining as much, the narrow, tiny buckets aren't necessarily going to catch as much. So you'll have a higher error rate when you're trying to measure how much water you've collected. Similarly, when you have a photosite that's this small, compared to when you have a photosite that's this small, you are actually letting a lot more error in to your particular capture of light. So what this means in real life terms is that this has to work a lot harder to capture the same amount of light than this has to capture. Okay? And what were we talking about when we have to increase the sensitivity for a particular sensor? We get more noise, right? So sensors that are this small are actually a lot noisier than, or well, in most cases, can be noisier than sensors that have the same amount of megapixels but are much larger. So similarly, if we had a sensor that was this large, or this small rather, and it was 4 megapixels instead of 8, now our photosites are that much larger, and we can capture, well, if it was a modern sensor, it would do a much better job, we would expect, to capture light than something with photosites this small. Does that make sense? Yes, question?
You're saying that both of those are 8 megapixels.
That's correct.
So
both of these are 8
saying,
megapixels.
You're saying that each pixel is much smaller in the smaller camera because the amount of the pixels are the same.
That's right. This is just, the megapixels are the same in these two sensors, but it's just a matter of scale. You have to, in order to make this sensor smaller with the same number of megapixels, you have to shrink the pixel itself. Okay. And so if in our buckets we had to get a certain amount of rain to be able to consider it a valid measurement, you would need a much bigger bucket to get the same amount of rain than a smaller bucket, for example. So does that make sense to everyone? So it's difficult to compare different years. So, for example, a sensor that's 8 megapixels and has photosites that are very small, in this case, may still be better than a sensor from 5 years ago that was much, much larger. It just depends. That's just a matter of advancement of technology. So when I'm talking about this, I'm really talking relative to technology for a given period of time. So when this makes sense, we can only compare this to cameras of the same time period. Okay? So, but there's another thing as well. Remember when I was talking about shutter speed? If you move the camera, or if the subject moves when the camera is taking the photo, it will appear to be blurry. Okay? So in 1 second, quite a bit can happen. I can get from here to right there in a second. Okay? But in 1/1000th of a second, I don't move as far, right? Because, well, it's hard to move very far in 1/1000th of a second. So let's consider then the size of these photosites again. If we have a very small photosite, so let's see, we have, in this case, let's just consider this, instead of to be 3300, maybe it's 2250 pixels as the width. Just bear with me for now. So let's say that this has 2250 pixels as the width, okay? But the physical dimensions are 22.5 millimeters. So what then is the size of each individual photosite? Well, that would be 0.1 millimeters, right? So that means that in the time, I'm sorry, 100? Yes. Oh, yes, you're right. Sorry. So that's what, about 10 microns, I think. 10 microns. That is not a lot of distance. If you move the camera, in the time you're taking the photo, if you move the camera 10 microns, the light is going to move from one photosite to the next one, and you're going to get a blurry photo. 10 microns. That is not much at all. So what happens here? If this then, this is about a third, so now we're talking 3 microns, or 0.03, or no, 0.003 millimeters, you now have a lot less space to work with to try to get your photo sharp. Okay? In any case, I recommend tripods. If you have anything that's going to be, half a second or longer, maybe a second, 2 seconds, you definitely have to have a tripod, because I guarantee you it's difficult or near impossible to hold a camera within a 10 micron tolerance while you are taking a photo. So this may happen to you if you're trying to take a photo inside of a church, for example. You're not allowed to use flash. You're trying to get a photo of the gorgeous ceiling, maybe, and you move the camera just enough, your photos will look like this. Very, very blurry, very, very shaky. And it's for this reason that the light is moving from one photosite to another. Yes?
The same thing is true of film, isn't it?
Yes, the same thing is true in film. Although film doesn't have photosites, it actually has chemical granules that modify. But yeah, the same thing is very true in film as well. Yes, that's why the analogy still kind of works between digital photography and film photography, is because it's fairly similar.
The smaller the piece of film, the more difficult it is to get a sharp picture. That's why people like.
Yes, exactly. For a smaller bit of film, it's difficult to get a sharp picture. But that's also because if you have a smaller amount of film, you can't. In a smaller piece of film, you can't have just as much resolution as you can in a big piece of film. It's pretty much fixed resolution between sizes of film. So if you want to have something with a lot of detail, you actually have to have a physically larger piece of film. It's just that we live in an age where the technology allows us to have smaller photosites in this case. But does this make sense? Does this illustrate? Hopefully that, tripods then, even if you have a really cheap tripod, as long as you can try to get it to hold still, it will help out. You know what? Even wind. If you're sitting there, the big heavy tripod, I have mine here as an example. This tripod is a weapon. It is a good 6 or 7 pounds. It's made of metal. I could bludgeon somebody with it if I wanted to. But
It also does a job on your back.
Sorry?
It does a job on your
It does
back.
do a job on my back when I'm trying to carry it around. But if I put it somewhere, it's not that likely to move once I get it somewhere. But the wind can make it move just enough that I can get a blurry photo. So there's so much that you have to take into account. And especially now with these smaller ones, let me tie this back to what I was talking about before, where bigger is better and more megapixels is not necessarily better. If you have 8 megapixels versus 6 megapixels, but you're wasting those pixels because you're moving the camera that extra micron or something, you're losing the extra resolution that you bought. So even though you have that option there. I mean, under ideal conditions, yes, 8 megapixels is better. If you can get a good tripod, lots of light, a very good setup, you'll be fine. But when does this happen? We don't have studios in our homes, so this is very difficult to achieve. So while 8 megapixels, yes, it does indeed give you more resolution, I argue that under most circumstances, 8, 10 megapixels now, I think, are coming out in some of these cameras. It's not necessarily... Right, yeah, Canon recently came out with the new 10. And so you can actually go online. I have some websites listed at the end of the notes where you can compare the photos taken by different cameras, and you can tell a huge quality difference between a sensor of this size and a sensor of this size. The difference is uncanny, really. So, do you have a question?
It is uncanny in that you can't go nearly to the extremes.
How so?
The newer SLRs give you a shutter speed from 10, 20, 30 seconds up to
yes.
an 8,000. Right?
Correct. Beyond...
The smaller ones will be a much narrower. Same thing with ISO. You can't, on a small camera, go above 400.
Correct.
Newer camera, you can go to 800.
Correct.
Within this,
sorry.
The range of reasonable light conditions,
mm-hmm.
the small ones still can do a remarkable job.
Yes, no, don't let me hinder you. The small ones can still do a remarkable job despite all of this under normal conditions. If you're taking photos in the sun, it can still do a very good job. And like you were saying before, just to repeat for our friends on the podcast, beyond the sensor, there's also more extremes in terms of the exposure values, the exposure options that we have in some of the SLR cameras, the more expensive cameras perhaps. And that is the difference that you have to take into account when you are out buying a digital camera. Do you want the ability to push this down to 1/8,000th of a second, like many cameras with shutters can do, or do you only want 1/1000th of a second? I mean, does it really matter at that point to you? So these are all things that you can take into account, and hopefully now, with a little bit better understanding, you'll be able to go home and make a better choice. But we were talking about sensitivity. So SLRs, SLR stands for single lens reflex camera. And it's the cameras that we typically associate like this, to have this shape and appearance. The reason that they're called single lens reflex is that you can change the lens on these cameras. Normally, on typical digital cameras, you have a fixed lens. You cannot change it. But typically, the SLR is a little bit bigger, a little bit more expensive, and they typically have just a tad bit more options. And one of them is this larger sensor area. What this means is that now that you have a much larger sensor area, you don't have to amplify the signal. You don't have to amplify the light as much, so you can have ISO values up to 1600, up to 3200, without it looking too grainy. Whereas with these much smaller cameras, if you try to push it up to ISO 800, you will often start to be able to tell. Sometimes it's not even usable. To be honest, I'm not sure on the very modern ones how good ISO 800 looks. I'm sure it's better than it was just a year ago, but still, the option is not there. So if you take a lot of low light photography, indoor photography with no flash, you need to have higher ISO options. So you may have to consider going to a larger, more expensive camera for that reason alone. Does this make sense, how we're all tying it back? Okay, good. Yes?
For people who want to take people pictures at parties
mm-hmm.
and always have it with them,
mm-hmm.
You don't have a big SLR. You have
no, right.
a small one.
Yes,
and that's a part of the trade-off. Right?
Yes, the trade-off is the size. If you need to sneak a camera into a concert, for example, you don't want to try to put an SLR in your back pocket. You would instead get one of the very small ones. It would suffer in terms of image quality because not only is the sensor smaller, but the glass, what we call the glass, the lens, also cannot be as high quality. Then it suffers in terms of that, but you will get a picture, whereas you would not have gotten a picture because you couldn't bring the camera at all. So when it's a matter of getting the picture or not getting the picture, you also have to take that into consideration. I mean, there's a lot to take into consideration when purchasing a digital camera, certainly. So, okay, so Any more questions before we move on?
Yeah, which Canon is that?
The Canon I have is called the 20D. It is, it's about 2 years old now. It's been replaced with the 30D. But okay, so let me take the megapixel thing another way. Like I said, megapixels don't matter that much. So I have two photos here. One is from my 20D, an 8 megapixel camera, and one is from a 5 megapixel camera that I owned before this. Can you tell which one is which? Which camera is which camera?
I think the one that's on the left.
One of them is 5 and one of them is 8. Any ideas? No. Doesn't affect the picture, right? That's because we're showing it on the web, right? If your primary use is to show it on the web, does it really matter to spend the extra $100 on an 8 megapixel camera? We'll go into more about this in just a little bit, but let's take a 5-minute break. Okay, so like I was talking about before the break, one of these is 5, one of these is 8. Now, I'll just clue you in, the one on the right is actually the 8 megapixel image, but on this screen, it doesn't matter. So this is another thing you can take into account. You can save money on purchasing a high megapixel camera if most of your shots are going to be displayed online, for example. So there are many things that can affect the quality of your photos. Some of them are the glass used in the lens. There's optical distortions, there's chromatic aberrations, achromatic aberrations. There's all sorts of stuff that we can get into later if you want. The sensor and electronics area. This is the one where I was telling you bigger is better for the reasons that I listed before about the sensor sites. Also, a huge thing is the output destination. If you're going to be printing out your photos, you probably want a higher megapixel camera so that you can print larger photos and get more detail without it looking jagged from the pixels. But if you're just going to be showing it on the web, even a 4 megapixel camera will have such a great area on the photo that it will be bigger than the size of your screen. So, you would be set with a relatively low megapixel camera. Most of all, though, affecting your quality is your patience, your practice, your luck, your knowledge of exposure, how much you're willing to explore with your camera. It's very much your understanding of the limitations, the physical limitations of the camera, as much as it is the camera itself. In fact, I'm just going to go off on a short tangent here. What really bugs me is when I walk around with the camera like this, and people say, "Wow, that thing must take great photos." And I said, "Okay, well, let me use your camera, and I'll take a photo of you," and I chop off their head. And I say, "Oh, yeah, your camera did a terrible job because it chopped off your head." It's not necessarily the camera that takes the photo. You're still controlling the camera of the photo. And there's actually a web comic online called whattheduck.net, and it deals primarily with photography and the issues that pro photographers are having. I'm nowhere. I don't claim to be a pro photographer, but the quality is still funny enough that you can understand. Whattheduck.net, and it's a web comic regarding photography and the issues presented to photographers now that digital photography is making it easier for amateurs to enter the market and basically undercut prices of the pro photographers. So, this opens up a whole can of worms that, if you want to take it in that direction, we can, but it's not necessarily something that we have to discuss right now. But certainly, your knowledge, if you can understand the exposure settings that I talked about, how the ISO relates to the aperture and to the shutter speed, the advantages and disadvantages of each of these things, and we can go over them again, then you will have so much power that you will be able to take a photo and you won't have to feel lost. You won't have to try to take a photo and guess and what we call chimp over your camera and try to see if you got it right. What I mean is chimping is usually people are looking over their camera and going, ooh, 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 just like monkeys would do. And it's kind of a funny phenomenon, but we all do it. So when you make fun of somebody, you call it chimping, but when you do it, it's, you're checking your work. So, okay. So if you're having trouble purchasing a digital camera, try this. Here's just a few tips. So consider your abilities. What do you want to use it for? Like I said, do you want to use it primarily indoors? Then you might want to consider a camera that has better low light capabilities, better or a higher sensitivity range. Do you want to use it outside for sports? Then you may want to use one, if you're going to buy one with a fixed lens, one with what's called a longer lens that has image stabilization so that you can zoom in really far. Let me go off on another tangent and talk briefly about image stabilization. This is not necessarily a recent development, but it's only now entering in the consumer market for digital cameras. And it is actually, if you have a lens, you have a small element in the lens. If this is your film plane, you have a small element that's actually on some motors. And there's a sensor that detects when the camera is moving, and it will move this lens up and down and also left and right. And so you can actually hold a camera that has image stabilization. You can hold it for a shorter shutter speed, a longer time with the shutter open, and it will still appear sharper because this literally kind of bends the light to be the same place so that the same light will enter the same photo site. These do a great job. They do miraculous things, but it's not foolproof. And if the person is still moving, like it won't stop movement, it'll only stop your own movement. So if you're taking a photo of someone walking and you're taking a 1 second exposure, that person will still appear to have moved that distance. It's just that the background, for example, may still appear to be sharp if you try to hand hold this. So you may want to consider something like that, where even if you're very, very zoomed in, you can imagine that, if you're holding binoculars and you move them just a little bit, you know how much it shakes. It's a similar thing. The image stabilization for a very long lens can help with a phenomenon such as that. Consider also the camera size that you would like. Would you like one that's an SLR size? I mean, it's good, but everyone knows you're taking a photograph of them. Or do you want something much smaller? That's, I don't have an example, but much smaller. Also come up with a price range. Digital cameras come the price range from $100 now to at least $8,000 for an SLR, and that doesn't even come with the lens. So once you've kind of figured this stuff out, do your research. Here's a couple of websites. dpreview.com. It's Digital Photography Review. They review all sorts of cameras. They have a good forum with people that are helpful and, for the most part, willing to help out. And actually, as we'll come back to later, they also have a glossary that goes over a number of exposure terms and other terms that I've talked about here in a bit greater detail. So this would be a good way for you to start your research, at least into the technical terms. But you can go to this website and just view different reviews for different cameras. And they even have sample photographs from each camera, so you could compare. They compare the ISO, the amount of noise in the different ISO values for different cameras. So you can see, for ISO 400, this camera is completely terrible. This camera is okay, so I might want to consider that one. Imaging-resource.com is another good one. They also have very, very in-depth reviews, sometimes even more technical and even more in-depth. But it depends on your own personal taste which one you want to go with first. So, like I said before, don't necessarily go by megapixel. It's a factor, but it's not the most important thing. Get enough megapixels for what you need, and don't worry about it. Consider it a luxury if it's going to be more expensive, for example. Basically, modern digital cameras have enough megapixels for 4x5, 5x7, even 8x10 photos that are very sharp. I believe some people say you can get away with 3 megapixels at 8x10. I think 4 megapixels is the minimum. 5 is even better in that case, of course. But it's completely up to you. You can even make larger prints. But if you're not going to print very much, then don't worry about it quite so much. So digital cameras have lots of dials, don't they? Sometimes they come with manuals that are larger than the camera itself. You don't know what everything does. So basically, a lot of them just have different settings that try to be smart for you in terms of, well, I don't have it up anymore, but the exposure settings that I was talking about. So they might have a little guy running, for example, and this will try to increase the ISO and increase the shutter speed because of sports. You want it to be as high of a shutter speed as possible. Then there is like a portrait one, for example, where it will open the aperture up as wide as possible, because then you will blur the background and your subject will be the model that you're taking a photograph of. But now that you understand, or at least hopefully have in the back of your mind, the way that these things affect each other, you don't have to use these simple modes anymore. You can go to the more advanced modes and try, experiment a little bit for yourself. Try to figure out what works best for you. Personally, I use the aperture mode. I think it was like 95% of the time, just because I know how in-depth I want my camera to be. Then I can set the ISO separately for about how much light I think, and the camera will tell me a shutter speed. If it's not an acceptable shutter speed, I can then change the aperture. I can change the ISO, remembering how they all affect each other. And this helps me come up with a plan. Like I showed you the star trail from the lake. I guessed at first that 7 minutes would be enough, but it wasn't, so I could change it at that point. Let's see. So there's also a self-timer on many cameras. I'm not sure why I mentioned that. Most people hopefully know what the self-timer does. In some cameras, it's 10 seconds, but they have an option where you can change it to 2 even, which is useful because, yet another tangent, these SLR cameras differ from the smaller cameras in more ways than just the size. It is that on the inside, the reason that they are a single lens reflex is there exists a very small mirror inside here. This reflects the light that's coming in through the lens up into the viewfinder where I'm looking. So what I see is literally what the lens sees, or what the sensor will see. When I take the photo, I'm not sure it'll let me do it now. It did. When I take the photo, the mirror moves up, the shutter opens, the sensor is exposed. The shutter closes, the mirror moves back down. That's that noise that we're all familiar with, is the clack of the shutter. Now, the smaller the smaller digital cameras have an electronic shutter, where you normally view the screen at the back. So the sensor is actually showing a live preview of what's happening. When you click the button, then it starts recording and stops recording basically for the given shutter speed that you set. But what this means, because we have a mechanical shutter here, is we actually have movement within the camera when the mirror comes up and when it comes back down. As you saw, it was very, very quick movement. So at certain shutter speeds, at about, I think it's like 1/6 of a second or so, it's enough to jerk the camera up and down so that you have a blurry shot. So we have, in that case, many of these cameras come with what's called mirror lockup. This is especially true even in film cameras. They had this where what you do is it locks the mirror up first. You frame the camera, you turn on mirror lockup. It moves the mirror up so that the vibrations stop. And then when you push the button, the shutter opens and closes. And the shutter opening and closing is relatively much less. So this helps reduce vibration as well. So that's one reason why you would want a 2-second self-timer, for example, so that you could frame it, set the mirror lockup, and then in 2 seconds it takes the photo after the vibrations have gone. So shooting modes, I talked briefly about them, like the little guy running. There's the portrait one. There's even a night mode one, and there's a whole bunch of them. I think in most cases you can infer what the shooting modes are trying to do. So you have an example of one, right? So is there one that, do you mind if I take a look here? Okay, so let's see. We have one here where there is a person with the moon behind them. So what would we think this camera would try to do in that case? This is kind of a trick question. So it's going to be a night shot, a portrait night shot. So what it's going to do is actually have a flash, right? So it exposes the person, and then it's actually probably going to leave the shutter open for a little while longer so that the background has enough time to expose. So when you have a flash, what's interesting is that you can actually kind of do two exposures at once, if you will, just in that when you have the burst of flash, the camera records that, but the rest may not have filled in for another couple hundredths or thousandths of a second. But if you, hopefully telling you this, you'll be able to recognize this, and in the future you can say, okay, sounds like a good time for me to use flash and a longish exposure with a tripod, of course, and then you can get a very nice looking, well-exposed person that's still, because the flash flashes very quickly, and a very nicely exposed background. Then the others I talked about were, the portrait, the sports. There's a macro mode as well, but that can also change the lens itself. Flash, I think flash is very much a matter of choice. I don't like flash that much. I would much rather bump my ISO up to 1600, 3200, get a bit of grain in the shot, and get the natural lighting from the room than deal with flash. And that's because the flash tends to have a different color temperature than, say, the rest of the light. So you can have a flash and the person will look blue, and the background will look very red. If you're in an incandescent room, for example, no, I don't really like that. I prefer to have the natural lighting. It's, of course, up to you. There's another problem with flash is that when you take a photo, you often see shadows right behind the person, and that's because the camera can only see where the light reaches. And since it's usually right above the camera itself, if there is a person right here, the flash comes down and actually creates a shadow underneath. It would actually create a shadow underneath my hand, which the lens would not have any information for. But flash can be useful if you buy an external flash unit, one of the ones where you see people holding it up or they attach to the top of their camera. That actually moves it up enough where the shadow moves out of the frame. And so you can actually get quite good flash shots with a situation like that. Sometimes, though, of course, you do have to rely on flash if it's a matter of getting the shot or not. Let's see, night shooting. Night shooting is difficult. You need lots more equipment than day shooting. You need a good tripod. You have to have lots of patience. You have to have a camera that can handle, several seconds or several minutes of exposure. Tripod is a must in cases like this. Sometimes you can get away with just setting it on something sturdy and taking a photo, but sometimes this doesn't always work. Now, JPEG versus RAW is pretty much the only thing on here that is specific to digital cameras. These are two different file formats that most digital cameras can take. Now, most digital cameras, when you buy them, you bring it home, start taking photos out of the box, it's going to take JPEG photos. These are normal photos that we're used to. Photos that you see online are JPEGs. The examples that I showed above were JPEG files. But you can also switch to RAW. Now, what RAW does is it actually takes the raw data from the sensor, which is why it's called RAW, and it writes that data. It doesn't process it at all, just writes that data onto the memory card. Then when you bring it home, you don't have a picture that's ready to send out. You have to process it, but it's somewhat akin to a digital negative, if you will, because then you can go through and you have somewhat of the same types of control that you do over film negatives. You can make it a little bit brighter, you can make it a little bit darker, and you have a bit more control over it than you do with JPEG. We talked briefly, at least those of you who were in the class and at the Photoshop section, we talked about the various bit depths of JPEGs. So JPEGs can have 8-bit color information. So this means that for every pixel, there's a red, green, and blue value, and this can vary from 0 to, okay, what? Here's the test. What's 8 bits? Yep, 256. So we have 256 total values, so 0 to 255, right? No, it's fine. So that doesn't seem like a lot. So all of these photos that you see, each pixel has a red, green, and blue value of 0 to 255. Now, luckily, when you multiply all of this together, you actually get a 24-bit total image, which is, so you get a total of 24 bits, which is actually pretty good. That's like 16, is that 16.7 million? See, I don't even remember. David would be mad, but it's actually quite a large number, and so you'd have good gradation. However, when you take a raw photo, you actually get, in many cases, you get 10-bit, 12-bit, and we're not quite up to 16-bit, but 10 and 12-bit are pretty good. And so I don't actually know the exact values of these, but it's that means that this is multiplied by 2 twice. So we actually have probably up to 1,023 color options in each case. Sorry, that was 16? Yeah.
That would be 16.
Yeah, I messed it up.
Whatever.
But anyway, so
It's a lot more.
Yeah, that's the perfect E1 answer. It's a lot more. And so this means that you have more natural color gradation. So if you go into Photoshop and you manipulate your photo such that you want to pull out a little bit more color out of it, you can, because you have that much more information. You're not trying to make information up. So when you're using a raw file, you actually have a lot more control over its exposure, its color, than you would if you have a JPEG file. So raw versus JPEG, raw files are actually a lot more work because you do have to modify every one. You have to make sure that it's set at the right exposure that you want, that it's got the right color and everything before you can convert it into a JPEG. Yes?
In my own experience, one of the big differences is that when you take a JPEG picture in a digital camera, typically it will sense what the proper color balance is.
That's correct.
Whether it's incandescent or whether it's sunlight or whether it's cloudy, and it adjusts for that. Raw doesn't adjust, and so later in the software you can change from what it would look like in incandescent to what it would look like in bright sun.
That is absolutely correct.
And it gives you that much more range of flexibility.
Yes, in the JPEG files, the camera applies what it considers to be the correct color balance. So as you know, in fluorescent lighting such as this, if you were to take just a regular photo, it would appear to be a bit more green, for example, than if you were in an incandescent room. The reason this isn't an issue with digital cameras is that it basically somehow figures out what it thinks is the color temperature of the room, and it adjusts. When you take a raw file, when you take a photo that's in RAW, it does not apply this information to the photo yet because it's not processed. So you can go back later, and in software you can actually change if the color balance isn't right. For example, mine tends to make photos that are kind of warm in incandescent lighting. It kind of goes a little overboard, so I like to just pull it back a little bit, make it look a little more natural, where I could not do that if it were JPEG because it's fixed. The color information is fixed. And especially since there's less bit information in the JPEG, you have less control over the amount of change for color. So RAW does have its uses, and you can certainly save. I've saved photos by using RAW than I would have if I had tried to take JPEG, because it also, with this much more color information, also at the very dark ends and at the very high ends, it saves more information, and so you can sometimes rescue photos that in JPEG would look overexposed or underexposed. Okay. So before we move on, is there anyone that has any questions about cameras or camera settings or anything like that? Yes?
Just going back to night shooting for a minute.
Okay.
And you put your camera on a tripod.
Okay.
Will the typical SLR digital camera determine the exposure length that you're going to need,
Yes.
even though it's 5 or 7 minutes or something like that?
So most digital cameras, including SLRs, do detect automatically the exposure up to a certain degree. Once you get past its advertised value, so for example, my shutter speed range is 1/8,000th of a second to 30 seconds. It can pretty accurately guess the exposure values that I need for this range. In fact, it does a very good job up until about 15 seconds or so. But in the case of that lake shot that I showed you where I needed 7 minutes, it had no idea. And so you have to switch it to a different mode where you actually hold down the shutter, and that's how it knows how long to hold open the shutter. So in many cases, yes, the camera can determine fairly well the proper exposure for a night shot, but it does have some troubles because there tends to be a lot more very, very bright things, such as street lights, and very, very dark things in a night shot that are difficult to get. Like if you were, let's see, we were on the Charles River and we were looking in Boston. Because of the sun, most of the exposure is fairly uniform. So the light is bouncing off of the buildings, for example, in the water, and we see a fairly uniform amount. But at night, the buildings are very dark, but the street lights are sources of light, and so there's a lot of contrast. And so I think that kind of confuses many cameras to a certain degree. But yes, up to the advertised range, the cameras tend to do a pretty good job. I think a lot of consumer cameras are 1/1000th of a second to 15 seconds. And for this range, they will do a fairly decent job.
Well, if I could just go back to the part of the answer where you said if it's like 7 minutes or something like that, you have to hold down the shutter.
Yes.
And then the camera will tell you how much it needs.
No, so if we are using, some cameras have what's called, well, they have this range. They also have what's called a bulb mode. Now, not all cameras have this, but in bulb mode, what this means is that you have full control over the shutter speed. So as fast or as slow as you can hold down the shutter button on the camera, that is when the shutter will be open. In that mode, the camera pretty much considers it to be manual. And it'll say, okay, I'll just let the user figure out the proper exposure.
So for a longer exposure, you have to guess what it's going to be.
For a bulb exposure, you do have to guess. You can generally do that if you take one photo. With digital photography, it's much easier than with film because it's trial and error, and you know right away whether or not your exposure was right. And so that's one of the reasons that digital photography is so much better. Just in terms of night photography, you don't have to guess your exposure and miss out on a great maybe star trail shot because you thought it was 14 minutes instead of 30 that you needed. Okay, any other questions? Okay. So you've taken photos. Now what? Well, of course you put them onto your computer. So there are a couple of options. You can move them into iPhoto on a Mac. iPhoto comes with all Macs. Or you can move them into Windows Explorer in Windows. Or you can download Google's Picasa. I think that also allows you to organize digital photos on Windows machines. There's a couple different ways that you can transfer the files from your camera to your machine. I have two examples here. One, this is a little USB device that allows me to take the memory card out of my digital camera into the device and then transfer it via USB into my computer. So if you remember, I actually took a few photos with the lens not on, but we didn't get a chance to see what those photos look like. So this will be a good opportunity then to see not only how they looked without a lens, but how the computer reacts when we plug in a digital or a memory card. So in this case, this was configured such that, or I had opened iPhoto already before I came here, and it asked me, when I connect a digital camera, do I want iPhoto to open? And I said, sure, why not? So I did that. Now that I've connected it here, you can't see it, but it's connected, it does allow me to import the 2 photos that I took. So by clicking import, it then moves the photos onto your hard drive, and in most cases it should not delete them off of the memory card. So they're still there. They just made a copy of it. It should transfer. So and then you can then organize them as you wish. So another way to do it would be, which I find slightly more annoying, is to actually connect via a cable the camera directly to the computer. Now this is kind of cool because with some cameras, particularly with SLRs, you can then control the camera with the computer. So what I did years ago, we had a lunar eclipse in October. Oh, that's something completely different. So what I did in 2004 during the lunar eclipse was, I think one of the Red Sox games was on in the World Series, and I didn't want to miss out on either the eclipse or the game. So I set my camera and my computer outside in the cold and told the computer every 30 seconds to have the camera take a photo. And so I got the arc of the moon across the sky every 30 seconds. And so with some cameras, it is possible with the direct USB connection, but not with all of them. So what's happening here? Uh-oh. Right. So I think what I should do, I have some other photos here as a backup. Thank goodness I did that. So here somewhere is the original, oops, I have the original photo of the star trail, and we can import that and take a look, see what it would look like if this would decide to behave. Right, so technical difficulties, of course, at the wrong moment. So what you can do, I'm going to use another program called Aperture. This is actually one that I use personally. I don't use iPhoto because I find it somewhat limiting. There are many more advanced programs that can help you manage your photos and modify your photos, but you have to pay for some of them. So let's see. Okay, open. So right here, now we have, it's importing some photos. It changes from one application to another, the specific steps for importing your photos, but for most of them, it's pretty much the same. You click import, you find your memory card, you plug it in, and you import your photos. So here, this is from my my road trip to New Hampshire this last weekend when I decided that I was sick of Boston and didn't want to be here anymore. I have here actually the original star photo. Let's see. So it's kind of small, isn't it? Okay. But let's take a look at some of the things that we can adjust. This is, in particular, a raw photo. So I have quite a bit more leeway, as I mentioned before, over its contents, over its fine-tuning, than I would if it were JPEG. Let's see. Oops. Okay, here we go. This is better. Now, hopefully you can see from the photo that the stars were actually moving. This is actually pointed somewhat northwest, so that you can see that as the Earth was rotating, the stars were moving around the North Star, which I didn't happen to capture because I couldn't find it at that time. So we can mess with the exposure. We can either make it brighter or we can make it darker. Now, this is much more useful in RAW than it is with JPEG, because if you tried it with JPEG, you don't have as many bits. It's going to try to make up information where it doesn't exist. and you're going to get some weird artifacts in many cases. Saturation is good because saturation modifies the amount of color that you have. So you can either make your greens greener, for example. You can make your colors a little bit stronger by increasing the saturation of your photograph. Contrast basically makes the darks darker. It shortens the range, the dynamic range, if you will, in a certain way, such that now what was originally somewhat dark is now very dark, and what was before somewhat bright is now very bright. And so it looks kind of silly on my screen, but if we turn down the contrast, we can see that it approaches gray, because now it's compressing everything to be about one color value. In many cases, now I think that people at home that might have gotten kind of miffed about my discussion about megapixels, because they say, oh, I like to crop so many times. And yes, this is a pro about having a number of megapixels. If you have a lot of megapixels, you can then crop your image without worrying too much about losing too much data. So this is an 8 megapixel image, and if we crop out this much of it here, we can see that it still has reasonably good resolution for on screen. If we were to print something out of this size, let's see, this right now it's 1,000 by 500 pixels, so this wouldn't necessarily print out too well. You can see it's, you probably can't see it, but it's listed right there, 1,000 by 475. But this is one case where, yes, the number of megapixels will actually help you out quite a bit if you're going to crop your particular photos. So after you modify the photos, and there's a lot of options, you can share them with the world. What are the different ways that we can do this? You have, of course, you can put them on a CD. You can give them to your buddies. You can create a slideshow. With iPhoto, it's relatively easy. I think Picasso might also have an option to do it. You can also use many websites that have online services that allow you to post photos and share them with the world. The one that I use and that I think is pretty interesting is actually Flickr. Flickr with no E for some reason. So let's take a look here. This is actually a site where it's very much a community-based site. You post photos. People can post comments about your photos. They can look through your photos, and generally they say that your photos should be relatively public so that others can enjoy them. So let me show you my site. So I actually recently put up, you may recognize these as being the New Hampshire photos, and I actually got a comment on the Star Trail one, someone saying that they really enjoyed it. Now, of course, you can then add your photos to different what are called groups, and people can view the group. So, for example, this might go, if there was a Lake Winnipesaukee group, I could add it there. Yes, it's a long story. But you can add it to groups, you can add it to sets, and you can make different sets. So this one I consider to be a pretty good photo, so it's in my best of set, and it's also in my Lake Winnipesaukee set, or my New Hampshire trip set. There are, of course, many other services to share your digital photos. .mac is for Macs only, but it integrates itself with the applications that come with the Mac. So iPhoto, for example, make it easy to publish your photos to .mac. WebShots, PBase, Photkey, there's so many. Yahoo offers some. I can't even describe how many different places. These will help you resize your images in many cases, tag them, put captions on them so you can share them with the world. I kind of blew through this section because I wanted to see if there are actually any questions, because I think people mostly have a generally good idea about how to move photos on, but maybe you have a question from there? No? Okay. So how about some trivia? What would you say if I told you that this camera that took this photo cannot detect color. Would you believe me? Cannot detect color. Would you believe me? Yeah? Well, just because I'm asking. Or it cannot detect color. So when I was talking about sensors before, I was talking about the photosites. Now, it was, oops, what did I do with the other one? My discussion about the resolution of the photosites was only somewhat misleading. That's because I was following what is considered to be, I suppose, standard knowledge about, or just the standard assumptions about sensors. But typical SLR sensors cannot detect color. They detect colors, or they detect values from black to white, and that's it. What we have, if we were to blow this up, is we have 4 photosites arranged in an array with a color filter over it. So there's a red filter here, a green filter, and a blue filter. Now this actually makes a very large pattern. And, excuse me, so this makes a very large pattern. But actually, so you can see that by using this, it actually takes about 4 pixels on the sensor to make 1 pixel on the image. Okay? So for this reason, you are actually not getting as sharp of an image as you could. To get the true resolution, because you have to have 4 photosites for 1 pixel, to get the true resolution, you have to kind of shrink your photo down to be about a quarter of the size. Now luckily, digital camera manufacturers have gotten pretty good at writing algorithms that can not only use the 4 here, but can use, so it can use these 4 to create 1 pixel, it can use these 4 to create 1 pixel, it can use these 4 to create 1 pixel, but you can see that if we basically consider the crossing over of 4 pixels to make 1, that our sensors are supposed to have more photosites than they are advertised to have. And this is true in many cases when you look at the specifications of your digital camera. It may say you have 6.2 megapixels, and then it'll say in parentheses 6 megapixels effective. And what that means is that there has to be the extra row along the end here for it to try to figure out or try to gather what it thinks are the pixels. So this can actually lead, as you can imagine, to some bad guesses. It can lead to distortions in your image. So if you take an image, for example, of this carpet, I wish I could show it better, but it's basically a very fine pattern of lines. If you were to take a photo of it, you may realize that there's this weird effect. It looks like this wavy effect that kind of happens over it. You may have noticed it in some digital cameras. And that is because the sensor does not have the resolution that we expect it to, and it has to guess. It has to guess certain values. And so that is why we get a number of artifacts from digital cameras that we do not in film. Yes?
Did you say all digital cameras have this problem, or just SLR?
No, not all digital cameras. There are a certain subset. So this is called a Bayer pattern. Most digital cameras on the market, I believe all consumer digital cameras on the market use this. Mine uses it. My camera phone uses it. Yours probably uses it as well. But if there's another version called Foveon that has what appears to be a much lower megapixel imager. So it's typical for a Foveon one to have about 3 megapixels. Or maybe I think they might be up to 5 megapixels. But every pixel, every photosite is basically layered. And each layer determines a different color. So there's basically 3 sensors per layer. I forget what it is. I think it's like blue, green, and red or something. And that I don't remember exactly the order. But so for every pixel that this Foveon camera takes, it actually means a lot more because it's not guessing. So the photos are much sharper for a 3 megapixel Foveon than it would be for a 3 megapixel Bayer. So Foveon does, though, have some downfalls because the light has to travel farther for these layers underneath. It's blocked by the layers above. That means the sensitivity for these layers underneath has to go up. And what do we know about that? The grain goes up. So there are other problems with Foveon as well. Right now there's no sweet spot for these sensors. So you do have a choice. You can get the Foveon or the Bayer. But yeah, most of them use the Bayer pattern with the color filters on top of the digital sensors. Okay, let's see, how much time do we have? Any other questions about digital cameras? If not, we can go over even one. Actually, let me talk briefly about the quality difference between a large lens and a small lens. So hopefully all of us remember experiments, refraction experiments from when we were young. We would set up prisms in front of sunlight, and the prism would actually split, or it would refract the light, the white light coming in, into its components in color, correct? And we would see that along the wherever we had set it up. Everybody remembers this? We would use like a prism to split the color. This actually happens in camera lenses as well. So as the light enters the lens, certain frequencies of light, certain colors get moved to other places than other colors. So sometimes if you're taking a photo of a tree, for example, you have a tree branch here, looks like this maybe. Okay, I can't draw trees. It's terrible. Okay, and it's backlit, so the sun is back here. So you overexpose, let's say you overexpose the background. So the background, or the sky is all white, and you exposed it for the tree. What happens, and what you'll see in many cameras, is that there's a small purple fringe on the outside of it. And that's from the distortion that's caused basically from the similar effect from refraction as the light passes through the glass. And so when you have a very, very small digital camera, when you have a lens that's this big, you can't do as much to correct aberrations, what are called aberrations, from this sort of thing. So if you can buy a digital camera with a relatively large lens and a relatively small sensor, you'll actually do pretty well, because they might, well, size of course doesn't necessarily mean quality, but if you buy a large, good quality lens on your digital camera, it can do a better job of correcting for these problems. And you won't have so many strange artifacts and aberrations. Any other questions about digital photography? Or yes?
Keep in mind that clock is very wrong.
Yes, it's 10 minutes.
It's 5 minutes to 5.
Yes, I know. That's why. Yeah, I've been watching the clock down here, the computer clock. So, any other questions? If not, thank you for coming, and
Thank you.
have a great day.
Thank you.
Yes.